So, dear students, let us continue with our discussion on vapor compression refrigeration system. Now that we have discussed the standard vapor compression refrigeration system, and we have done several problems on that. And now let us look into how an actual vapor compression refrigeration system will be considered. Okay, so till now we have discussed the standard vapor compression refrigeration system and its modifications, and in that we have considered various processes. Okay, so there was a constant pressure heat absorption step or refrigeration step. Then there was a isentropic compression process, followed by again a constant pressure heat rejection process, and finally a throttling process or constant enthalpy process. But in an actual system, or when we are considering an actual refrigerator where these operations are carried out, actually no process can be ideal. Okay, no actual process can be ideal. In most of the practical cases, there will be several losses in all the actual processes. For example, our main energy consuming device is the compressor. Okay, so in a refrigerator, the main energy consuming device is the compressor. So now let us focus on our compressor part, especially our compressor part, because it is the largest energy consuming device when we are considering a refrigerator. Okay, so there will be a suction valve, or there will be a inlet valve. Sorry, there will be a suction line or inlet line where the refrigerant will be flowing from the evaporator and traveling towards the compressor. Okay, and during that travel itself, okay, we have already learned the friction losses in the fluid flow in our fluid mechanics classes. Okay, just like that, just like we can consider some friction happening between the fluid molecules and the inside of the pipe surface in which a fluid flows. The same thing happens here in our refrigeration system. So here we are having a piping circuit in which some compressor, then there will be some evaporator, then heat exchanger, then this throttling valve. All these things will be fitted. Okay, so just like we can consider a piping system through which water flows in a normal hydraulic system, we can consider our refrigerator system also working similarly. Here our working fluid is nothing but the refrigerant. More or less, the refrigerant will be existing between liquid and its vapor state while it is passing through various sections of our refrigerator. So when the refrigerant is traveling from the evaporator towards the compressor, there can be some amount of friction between the refrigerant molecules and the inside of that piping circuit or the connecting circuit. So there will be definitely some pressure loss happening wherever this refrigerant will be flowing. So when we are considering exclusively our compressor, there will be inlet line through which the refrigerant will be flowing from the evaporator towards the compressor. So there will be definitely a pressure drop happening in that line. Okay, then just before the refrigerant enters the compressor, there will be a suction valve or the admitting or the inlet valve. Okay, it will be an opening and closing valve. So definitely this fluid flow will be interrupted by this suction valve or the inlet valve. Definitely again some amount of friction loss and pressure loss will be happening at this suction valve. Okay, so again this compressor process, immediately after the refrigerant enters the compressor, it is followed by the compressor compression process. And in ideal case, we will be considering the compressor work as isentropic process, but isentropic process means reversible adiabatic process. No actual process will be reversible. So we can consider this actual compression process as a irreversible compression process or a polytropic compression process. Okay, then after this polytropic compression process, definitely this during the polytropic compression process, definitely there will be some losses compared to an isentropic compression process. Then immediately after this compression process comes the discharge valve, or the refrigerant needs to be discharged towards the condenser through another piping circuit. So just before it leaves the compressor, there will be a discharge valve. Again it will be a opening and closing valve. Definitely there will be some friction loss happening at this discharge valve. Again there will be a pressure loss happening at this discharge valve. Then immediately followed by then the next step will be discharging or outletting the refrigerant from the compressor towards the condenser. Again there will be a piping circuit or a pipeline connecting the compressor towards the condenser, and there will be definitely some other pressure loss happening when the refrigerant is passing through this piping circuit. So definitely another pressure loss will be happening in this piping circuit. So wherever this refrigerant is flowing inside our throughout our refrigerator circuit or piping circuit, there will be definitely some amount of pressure loss happening at each and every point. So when we are considering a performance of an actual VCRS or actual vapor compression refrigeration system, we need to consider all such pressure losses. So now let us try to represent the pressure enthalpy diagram for such a actual vapor compression refrigeration system. So this will be the pressure enthalpy diagram for an actual vapor compression refrigeration system by considering all possible pressure drops at each and every point inside the circuit or inside the piping circuit connecting all parts of a refrigerator. So here we can have 8 to 1. What can be that? Normally 8 to 1, this portion, it is our refrigeration step or the refrigerant flowing through the evaporator. Okay, so what can be that? 8 to 1 can be the pressure loss happening inside the actual evaporator. What happens when the evaporator flows through an actual evaporator? The refrigerant molecules will be experiencing some frictional effects from the surface from the inside surface of that evaporator. Okay, so there will be some amount of pressure loss, and that pressure loss is shown by drawing an inclined line from 8 towards 1. Okay, then what is meant by 1? 1 is the 1 can be the exit of the evaporator and the starting of the suction line towards the compressor. Okay, so 1 to 2, what can be that? 1 to 2, this portion, it will be the pressure loss happening in the suction line of the compressor. This portion, the suction line of the compressor, we have already discussed some friction loss will be happening at this suction line. Okay, so 1 to 2 is representing that. Then what can be this 2 to 3? 2 to 3 can be the pressure loss happening at the suction valve. Actually the suction valve is the suction valve is interrupting the actually it is offering a hindrance to the flow of the to the free flow of the refrigerant, and that is the duty of the suction valve also. But during this process, the suction valve is acting as a pressure drop. Okay, and that pressure drop is represented as 2 to 3. Then the actual compression process or irreversible adiabatic compression process or polytropic compression process. We can consider the compression process a general process or polytropic compression process, and that is represented by the inclined line 3 to 4. 3 to 4 over here. Okay, then after this compression process, the refrigerant will be admitted towards the outlet line towards the condenser. Before that, it will be flowing through the discharge valve, or the discharge valve itself will be acting as a hindrance to the free flow of the refrigerant. So again another pressure drop happening at the discharge valve, and that is represented as 4 to 5. So 4 to 5 is the pressure loss happening in the discharge valve. Okay, then what is this happening here? What is this 5 to 6? 5 to 6 is immediately follow the area or the portion of the refrigerator immediately after this discharge valve, that is the outlet line or the pipeline connecting the piping circuit connecting compressor with the condenser. That is another piping circuit. There will be some amount of friction loss happening there. So represented by 5 to 6. 5 to 6 is the pressure drop. 5 to 6 is the pressure loss happening in the discharge line from the compressor towards the condenser. Then followed by 6 to 7, that is our heat exchanger process. Heat exchanger is also having some piping circuit where the refrigerant molecules may experience frictional effects. Okay, so there will be another pressure drop happening when the refrigerant is flowing through the heat exchanger. So 6 to 7 is representing the pressure loss happening when the refrigerant is flowing through the heat exchanger or through the condenser. 6 to 7, the pressure loss happening in the condenser. And what is remaining? 7 to 8. 7 to 8 is the pressure loss happening in the expansion valve. 7 to 8 is the pressure loss happening inside the expansion valve. Already we have we are considering this in the standard VCRS because it is a throttling process. Definitely pressure loss is happening inside a throttling valve. Then followed by 8 to 1, we have already discussed, and the cycle will be continued. Okay, so this can be a representation of a actual VCRS. All of you learn this portion by drawing this pressure enthalpy diagram and this diagram. Okay, this can be asked in your university exam. So thank you.